Hello to everybody out there for episode 187 of Wissenschaft, fürs, Wohnzimmer, science for the living room, presented to you by the Avis for Future, which is a group of scientists from the Alfred Wegener Institute for Polar and Marine Research who think that it's a good idea to increase science communication. My name is Björn Zuko, and I work there in the Sustainable Marine Bioeconomy Group, trying to make the food from the ocean as sustainable as possible. And today's guest will just be talking about that. That is Friederike Ziegler from RISE, Research Institutes of Sweden. And as always, I'm not here alone, but with two of my beautiful colleagues.
Hello, everyone. So my name is Martina Zapponini, and I am doing my PhD right now at AVI in the climate dynamics section. And I just want to tell you that, of course, if you like the channel, please hit the subscribe button and like the video. We would be really happy.
Hey everyone, also from me, I'm Denise, and I'm also doing my PhD on permafrost cost. And we will be monitoring the YouTube channel in case you like to share your comments or questions with that. That is appearing on right side of your screen. And without further ado, I would like to give floor to our guest today. Over to you, Friederike.
Thank you very much. Let me see if I can share my screen. Is that all right? Yes, thank you. Thank you very much for the introduction and also for the invitation to be in this fantastic broadcasting almost from my living room to your living room about my research, which is a nice opportunity. And I'm a senior researcher at RISE, as Björn said, which stands for Research Institutes of Sweden, based in Gothenburg in Sweden. And my plan for this talk is to start a little bit in today's food system. Let me see if I can switch slide. Maybe there's little bit of delay. There we go. So to talk first about what is the problem with food production and the food system today, and what is the role of seafood in a future food system. Then I will present a specific study that I've been asked to present that we have finished a few years ago. We tried to align and map the climate and nutrition performance of different types of seafood in a study. And then I will finalize and talk a little bit about how can you think about choosing seafood, because that's after all what many people are dealing with every day when you go to the supermarket. So starting with the food system, this is what we know and we read about in the newspapers a lot. The food system is not delivering the services that we want, healthy and sustainable food for everyone. We have a lot of health problems coming from the way we eat and produce food, and we also have a lot of environmental problems. Actually, a lot of our environmental problems are very much depending on food production, like climate change and biodiversity loss are very heavily impacted by our food production today. And we talk a lot about the protein shift, and it often has these colors from red to green, and it's a very obviously positive thing. We know we should eat less meat for health reasons, especially processed meat, and we should eat more vegetables. That's almost true for everybody in this world. But then the question is there something missing when we have that picture, and that is something that almost everyone realizes is necessary to do. What is missing? Well, one thing that is missing is that we forget that we actually in the Western countries, we often overconsume proteins. So when we talk about replacing proteins, we don't need to replace all of the proteins that we eat, because we eat almost too much. And the second part is what is something missing in this picture of the protein shift and the food transition. Well, surprise, surprise, it's seafood is very often missing in these discussions. It's it's a food commodity. Everyone is eating it. It's not a novel food. It's something that is an important component of our food, but it's often not recognized as such. And why should we consider it as more important? Our many dietary advice. This is the Swedish dietary advice, but it's very similar in other countries. The governments of other countries, they advise their consumers to eat less meat, less processed meat, but very often more seafood. And in Sweden, they say you should eat seafood 2 to 3 times a week. I'm not sure about the German recommendation. And that is because seafood contains a lot of these nutrients that are popping up here, omega-3, fatty acids, selenium, iodine, and vitamin D, most importantly. And they are quite difficult, or they can be difficult to get in sufficient amounts from other types of food. And increasingly, this is also recommended for environmental reasons, but then it's important what type of seafood you eat. Vitamin B12 and iron were also popping up here. But then, what seafood to eat? That's the question, because seafood is, as opposed to land-based meat production or animal production, is a couple of animals that we have specialized in producing. But seafood is thousands of different species. We can fish, they can be wild caught, they can be farmed in different kinds of systems, and there is a big diversity. And I will show you one slide. This is the most, sorry, were you saying something? No? No? Okay. Yeah, this is the most complicated slide. I just want you to see here, there are a couple of groups of seafood listed, and then each graph is a different type of environmental impact. And you can see that for a reference, you have a brown stripe in the middle, which represents chicken, and then you can see the environmental impact of these different groups scale. And basically, you can see that the diversity is enormous. There are big differences between different types of seafood. That's basically what this graph says. And that diversity is going to the next slide. That diversity is actually the same in terms of nutrients. When you look at different species here, the names are in Swedish, but I think you will understand that the different species have different levels of these different nutrients, and therefore have a different value for people with different deficiencies or needs, nutritional needs. And a while ago, we became interested in these different, the health and the environmental impacts. So we chose these two dimensions, nutritional content and climate impact, and try to map different species from these two perspectives. So we did this in this paper that I was asked to present today. It's called Combined Climate and Nutritional Performance of Seafoods. And I worked with my colleague Elinor Hallström, who is a nutritionist, and they collected nutrient data for all seafood species that are consumed in Sweden, or all common ones, and they will be very similar to what is consumed in Germany. There's not a big difference in that. And then the nutrient content for a number of nutrients, I think 24 nutrients, were collected and related to the recommended intake, the amount that you're supposed to eat every day of these nutrients. And then this was summarized into an index. And then on the other hand, we modeled the climate impact per species. We looked into existing life cycle assessment studies for different types of fishing and farming and weighted this together. And then we ranked the species according to climate impact, nutrient density, which is the combined index, and that also looked at how much climate per nutrient density. And I'll show you these results. First, one dimension, in terms of nutrients, and then for climate. So if we start with nutrient, now I've made this arrow, so which starts at red. And red is in this case a low nutrient density, and we have scallop has ended up having a relatively low nutrient density. Scallops that are popular but not the biggest volume type of seafood. And then following here we have Alaskan pollock, also ranked quite low in terms of nutrient density. It didn't contain a lot of minerals and vitamins. Shrimp was also low, and then we have cod a little bit higher, salmon, and the highest were the pelagic species, sprat, mackerel, and herring, and also actually the oysters were very high in different minerals. So this is an example. I think we had 40 species in this study, but just to display a few of them here. And if we go from here to climate and do the same, so in this case now the arrow, the green is low climate impact and red is high. And we go from up, then we have shrimp and scallop, and actually oyster a little bit lower, but this was where they were ranking depending on the fishing and farming method, basically. And then we had cod and salmon almost on the same level for climate, and all the pelagic species ended up being very low. And yeah, this is one way to show it. In the paper we had a different, and Alaska pollock was actually on the same level as the pelagic species, sprat and herring and mackerel. And speaking of terms, pelagic means when the fish that is living in the free water mass, not associated to the seafloor. And in the paper we had this illustration, this graph that showed these bubbles. Each bubble represents one species, and the size of the bubble is showing the consumption in Sweden. So the biggest red bubble is farmed salmon, the big blue bubble is cod, wild-caught cod, and so on. So each bubble is one species, and you can see also the letters B, P, C, and E stand for beef, pork, chicken, and egg, for reference where other animal products end up. And you can also see that you have the average bar, and then you have the higher nutrition alternatives to the right, and you have the lower nutrition alternatives to the left. And the average means the average of the seafoods that we have looked at. So it's just a simple display of the data that we got. We continue. This is a more popular version of exactly the same graph, actually, that we also did in Swedish for a policy brief on this seafood consumption. So you can see you want to end up in the green corner of this graph where you have high nutrient density and low climate impact. And you don't want to end up in the left upper corner where you have high impact and low nutrient density. And then you have the yellow areas where you have some trade-offs between these two dimensions. So you can see the illustrations of some species here. But then what is it that causes the differences? Well, the conclusions from this work were that both production and consumption should obviously be focused on the most efficient production forms and species groups, and that replacing meat with low impact seafood is generally it's a good idea from a climate and nutrition perspective, but it's important to not choose the high impact alternatives. Then the dietary advice should promote species that have a high nutrient content and low climate impact. That's not the case as much today. And this advice could even take into account that different groups have different needs and depending on their consumption. But so what seafood is most sustainable is a question. I have listed the three most important factors or parameters for the two production systems, fisheries and aquaculture of seafood, and they are most important is that the stock or the species is sustainably fished. That means that we don't fish more than that does regrow, so that the stock will continue to thrive also in coming years. That the fishing methods used are non-destructive. That means that they are don't destroy ecosystems and also are not too energy intensive. So low fuel use is an important factor for the climate impact. And for aquaculture, the most important thing is whether the species is fed or not fed. So, for example, mussels, oysters, and seaweed and tunicates are non-fed species that just take the nutrients that they need from the water. And in case you don't know what tunicates are, this is how they look. They can be farmed and they can be processed to food and both food and feed actually. Right, and when a species in aquaculture does need to be fed additional feed, it's important that the nutrient requirements are not too high, that it can live from lower protein feed and perhaps more, maybe just partially fed and so on, so that it can live from sustainable feed. And the third one is the farming system as well, that it's an efficient system that doesn't need too much additional energy inputs or pumping of water or heating of water, and also a construction of different things. So the farming system also has an impact. And this is maybe seems complicated. No one, if you're not very specially interested, you will not know everything about this when you go to the store. So you have to rely on some information from someone, and there are actually ways to help. There are these certification systems or standards that you have most certainly seen on products. For wild caught, it's the Marine Stewardship Council, and for farmed seafood, it's the Aquaculture Stewardship Council. And there are also other, but these are the two most common ones on the market, I think, on the European market. And they show when a product carries these labels, it shows that someone has applied for this, they have undergone the certification process, and the product or production system passed this standard, so it fulfilled all the criteria. But there are a lot of misunderstandings about certification. So one thing that it doesn't mean, for example, is that a certified product always is much better or more sustainable than a non-certified one, or that all the certified products are exactly equally sustainable, because they can pass the standard with a margin or with a very low margin. So that's it's really just documentation that some criteria are fulfilled. And what is also important to recognize is that, or to remind yourself, is that some common perception is that the fishery is always forced to make improvements to become certified. But some fisheries are already, to start with, they fulfill the criteria, they don't have to improve, whereas others maybe have to work for some time and make sure that they fulfill all the criteria. So that's also an important thing to remember and notice. And yeah, so this can be important. I mean, I think that certification can help because it's complicated. You can see it as if the consumer trusts this system to do something that you are not able to do yourself. So it's the intention is to help, and very often it's can lead you towards the better option, or the best options. I would like to highlight here there is also this website that simplifies fisheries sustainability information, the Fiskbestände Online, which is made by the Tunen Institute, a lot to facilitate communication about seafood and or fisheries and sustainability. So there's a lot of information for someone interested also about non-certified seafood. Okay, maybe this sounds like, we will only eat strange things in the future, and we cannot eat anything of the things that we are used to, or that we normally like. We eat a lot of, in Sweden and in Europe, overall, we eat a lot of cod and salmon and shrimp. And maybe it sounds like we will only eat these different types of new seafood, but I think it will more look like this, that we have additional species and we can try new forms, but we can also keep eating what we eat today, and these conventional or traditional seafoods can be produced in a more in better ways as well. So there are a lot of improvements to be done there that I didn't talk about now. And that's basically the way, if we think about saving the planet, is there a nicer way than having a mussel stew or a mulfrit or a couple of oysters? That's not really a sacrifice to save the planet that way. So I think that's a good thing, a way to think about it. And that was what I had to present to you, and I'm really happy if you have any questions, comments, or now or later, or anytime. Thank you very much for joining and listening.
Thank you, Friederike. Thank you so much for this quite interesting presentation. So now, all of you out there, you will have the possibility to ask any questions you may have. So think about it good, and let us know in the chat. You write in the chat, and we will then ask those questions directly to Friederike. But in the meanwhile, I'll tell you what is going to happen in 2 weeks from now, which is a German-speaking presentation. So we're back into the German language. I'm sorry for those of you who don't speak it. It's a bit difficult, I know, but we're after all a German channel. It will be about the source to see concept, which is the question. So how can we basically take into account both land and the ocean when it comes to sustainable development in the future? And when we want to, keep our well, basically all the what we have there, we will need it for us to live with. That is fresh water. What do we do with those freshwater resources? How do we handle them, and how can we actually have a concept that takes into account both land and water, and in the end sustains not only us but also the planet, every living thing on Earth. And this will be presented by Tim Yanayan, a fellow colleague from the Center for Marine Tropical Ecology in Bremen. So, but now let's get back to you, Friederike. Let's get back to you. And there we are. And let's see if there's any question in the chat already. And I'm looking to you, Denise, is there?
Yes, we do. And I would like to start with the one from Luchen. My apologies if I'm mispronouncing, but the question was, what is the definition of nutrient density?
Yeah, that's a good question. It's a concept. I think it's only been used in research so far, but it's an index with the idea that you want one metric to reflect the nutrient density. It's a composite. It's an aggregated index composed of a lot of ratios. So if you take the content in 100 grams of seafood of each nutrient and divide it by the daily recommended intake of that nutrient, and then you do that for all the nutrients that are included in the index. You can modify that depending on what type of food and what you're interested in. We used, as I said, 24 nutrients. And so we took the content of, for example, iron, say 5 milligrams, and divided by the recommended daily intake. So we have this ratio, how much of the daily intake is in 100 grams, and then we sum these small ratios up to the index. That's basically it. And we actually had we made a difference between positive desirable nutrients and non-desirable. So salt and saturated fatty acids were instead subtracted instead of added to this index. But yeah, it's not a concept that is used in dietary advice in any way. It's on a research level.
Maybe, Martina, I just would like to jump in there. That's a good thing being the main host. I was wondering, as you just talked about the nutrient density, could you compare it to what you see a lot in other studies? That is the basically the CO2 equivalents or emissions. I think mostly with compared 1 gram or 100 gram of this and that will then produce that much CO2 emissions or CO2 equivalents. How do you see the comparison? Can you do that?
Yeah, it's not exactly the same, because when you calculate greenhouse gas emissions, and you give every greenhouse gas according to its the forcing index, it has a strength, so to say, for global warming, which is you can measure it by chemical reactions. So, for example, methane has a much higher number than 1 kilo of methane has much higher impact than a kilo of carbon dioxide and so on, and nitrous oxide. Whereas the nutrients, we don't calculate them in a common unit. We just calculate these ratios, how much do they contain, and then we aggregate them. And there are different ways of calculating this. We in this paper, we actually tested, I think, 4 different ways, and then we decided one. So we have presented all 4 ways in an appendix, because there are pros and cons with different ways. For example, some nutrients, if they are over the recommended daily intake you have a higher content than the recommended daily intake. And the question is, should it count? Because that nutrient is basically wasted. You cannot take up more than a certain amount. So in one of the ways, we just kept the nutrient content at the recommended daily intake. So it didn't give a higher nutrient index if it was higher. So.
So another question is, where do muscle fit in the climate and nutrient density figure?
Yeah, they actually in that paper we didn't have muscles, but I can answer it anyway because we have looked at it later. Because we didn't have nutrient data for raw muscles, and we had the nutrient content was in raw meat for all the different species, and there was in that database at the food agency there was no data for mussels, unfortunately. But we have looked at it later, and mussels are extremely low in inputs and emissions, and they are relatively high. They are over average, but not on the top in terms of nutrient content, because they do contain a lot of vitamin B12 and also a lot of minerals, and that is actually very important because there are some vegetarians that they do eat mussels, because depending on why you are a vegetarian or vegan, there are some people that choose to still eat bivalves, and they will give a very important nutritional contribution in that case, because it's really the nutrients that you would miss, like vitamin B12, iodine, and omega-3 fatty acids, and vitamin D as well.
All right, and then we have quite a few comments / questions from Jens Segebrecht. Greetings, Jens. So let me go through it. So we start off with, as far as the German consumer, he writes, is concerned, he is somehow not willing to spend money even if the concept is sustainable or more sustainable. So that is one of the questions. So he loves the idea. He's an independent salesman, but who will be able to afford it? As far as the German customer is concerned, is he someone not willing to spend money even if the concept is sustainable? And do you see a change, or do you see a chance, better to say, do you see a chance, Friederike, to change this, for example, via marketing or even social media or other means? Have you had success in that, or do you know people that picked up your data ideas and have actually changed the world a bit for the better there?
So do you mean if they have changed because the question started in the price, and that the price would be higher? I'm not sure the price has to be higher actually for sustainable food, because it doesn't have to be more expensive to produce. It's just a lot is actually not the responsibility of the fisherman in terms of wild caught. It's a lot is about the management system and how we do work with these common resources and how we take care of them. So it's the governmental agencies that have to create sustainable rules. And in that case, I don't see why a sustainably caught fish should be more expensive. But then I think the end of the question was more towards how
marketing. Do you see a chance or basically what I would translate it to is, do you see a chance to increase the consumption of sustainable seafood using, for example, marketing or even social media So basically, how do you get across information the best way in order to help us to choose the better?
That's a good question. I mean, if it's you can market it towards this very specially interested consumers that would be willing to maybe pay a little bit more for sustainably and maybe also locally caught or produced seafood. But I think the change will not. The big change doesn't happen until you actually change something that has a little bit larger volume and reaches more people in more simple ways, like through the supermarket or the frozen seafood counter. Or so that even if it's maybe a smaller change, I'm quite convinced that it makes a bigger impact.
Thank you. We have a following question from Lily, and she's asking, has the exposition to pollutants like mercury, cadmium, inorganic and organic pollutants also be taken into account, since shells especially are accumulating them? It could cause health issues. So she's asking whether you have any recommendations on that.
Yeah, we actually, in this study, we actually highlighted the species that have some kind of limitation for consumption in the dietary advice in Sweden. So that is related to, for example, fish caught in the Baltic Sea, fatty fish, and also for lake, like inland fisheries from lakes. There are also limitations for consumption in that. And so we highlighted that to make sure that even if it's super positive from a climate and nutrition point of view, that even if there is a limitation, that you shouldn't consume it more often than once a week, so that you are aware of that. Because that's very important. But actually, in recent years, the mercury levels in Swedish lakes have been going down. So they think actually if it continues at this pace, then in a number of years, I think maybe 10 or 20 years, they don't have to have this recommendation anymore to only eat freshwater fish. I actually don't remember now if it's once a month or how often it is, but there is a limitation.
I also would have one question that is more regarding the difference both in the climate impact and in the nutrients between wild and farmed seafood. If you have any numbers, or if there are any numbers about that.
That's tricky because both wild caught can be very low. If we talk about herring that is caught in big purse seines, many tons at the same time, it has a very low climate impact. At the other end, you have crustaceans, for example, like shrimp or Norway lobster, caught with demersal bottom trawls, and which have a high carbon fuel use and carbon footprint. And among the farmed species, you have the non-fed, like the mussels and the seaweed at the lower end, and you have the carnivorous, like fish that is on top, like of the top predators that are very dependent on feed input and maybe maintaining the environment. So like within wild and within farm, there's such a difference and variety. So it's really impossible to say something general like wild is better or farmed is better, but there are high and low impacts in both categories.
Thank you. Yeah.
Okay, we are coming probably to the last question. So if there's any more questions out there, please ask them now. Otherwise, I'll typically stop now after question 6 if you don't join us frequently. Let's see. So I was wondering, so both scallops and oysters are filter feeders, right? So, but they had a relatively high impact in terms of climate impact compared to, for example, other species. And I was wondering why I found it a bit counterintuitive. Yeah, so
Yeah.
could you tell me,
Yeah,
please?
that's true. For scallop, scallop are almost always wild caught, so they are dredged with demersal dredges, so that's almost like a bottom trough, and quite small volumes. And you also have a very small portion of scallops is edible meat, so that explains a relatively high impact of scallops. And the oyster is actually because the oyster is farmed, so there is no feed input there. And at the point of the study, there was actually only one LCA of oysters because we used existing LCA studies in this as a baseline. So we drew data from that, and that was a Scottish system with relatively high inputs. And we have seen since then there have been other oyster studies published, and which have lower values. So if we would do it again, the oyster would probably come out as lower.
Perfect, thank you.
Sure.
And do you have any idea why it is that seafood is often overlooked in those more general studies when it comes how to feed the world kind of studies? And then the question, so what should we actually go for?
Yeah. I think the reason it's often overlooked is because it's really a divide in capacity. People have either an agricultural education or they are marine or fisheries educated, and people working in the food area food is it's very often focusing on agriculture, and yeah, traditionally there hasn't been a lot of talking, and I think it's actually also due to the on the fisheries and aquaculture side. I think a lot of these institutions or agencies that govern, for example, the fisheries management organizations, they often identify themselves as they are the fishermen's organizations, but they don't see themselves as part of a food production supply chain in a way. So I think that's also part of the reason they see that they have to deliver on producing as much as possible, increasing the value, the landing value, but they are not involved in what happens after the fish or mussels or crayfish is landed and harvested.
Well, thank you so much for that insight on one of my most beloved topics. Thank you out there for everybody that joined in and everybody that still will be joining. Yeah, please share, like, and subscribe. I hope you liked it. There will be more content. There is more content on the channel. Everything you can find typically under live streams. There's more on seafood. There's more on how to feed the world in the future. There's English speaking playlist, everything you can find there. I'm very happy that you joined us here tonight. And thanks again to you, Friederike, and thanks to you and your colleagues for doing this work and getting us more of that interesting information and data so that we in our realm can, talk about that and spread the fact and spread the news of, how we can feed the world in the future in the most sustainable way. So with that, I say goodbye, good night, peace, and I hope to see you, for example, in 2 weeks when we hear more about the sea to source concept and how we can safeguard our water. All right, bye-bye.
Wissenschaft fürs Wohnzimmer.